Hello, Tom from Every Step Calculus, everystepphysics.com. This is a calculus problem regarding double integrals. And after I get done, maybe you can subscribe. There's a little tag on the bottom of the screen if you see it to the end, or and you can click on that and subscribe for more videos, of course, and maybe even share this with somebody else in your classmates or something. Let's do this. I'm going to show you how good my programs are to teach you how to do this. And I put down the answers. This is a Yahoo answer here, a problem and an answer. And here's problem number 1, and then there's a problem number 2. And I'm going to show you how a sane way of doing double integrals goes, okay, compared to this, which is completely nonsensical. Can't even understand what is going on. Press enter to get to my menu. You're going to put index 8 to get to my menus. These programs are $40. If you go to my site, you can buy them for $40 and have them and pass your calculus class, you know, and tests. We're going to scroll down to double integral on the menu that comes up. I'm already at double integral here. Save time. Press enter. And we're going to enter the function. The first function is x times y plus y squared, okay? Press alpha first. X times y plus y squared. Press enter. Looks pretty good. Change it if it wasn't, and we want to do it dy dx. Okay. And let's see where they say to do a d rectangle consisting of all points x, y such that x is 2 and y equals 3. Calculate double integral interpreting it as a volume. The volume in the integral is x. So I'm not sure why you would do it dy dx. They have ax and bx here and ay and by here. Now this person who answered it has it dy dx. Okay, so we're going to do it that way. Number 2. Press enter, and I'll show you what's happening here. Here's the limits here, ax bx and ay by. I'm going to do a dy to d. This is the way you write it on your test paper, whatever. And you're going to enter the ax and bx, okay, which is, what is it, 0 and 2. So we're going to put alpha 0 and alpha 2. Ax 0 and 2. Okay, that looks good. We're going to say OK. Ay and by. You can do it both ways, you know, if you don't know this, just like we didn't know here what we're supposed to do it dy dx or dx dy. So you can do it one way, and if it doesn't come up with correct or sane answers, then do it the other way. It's the only way I would know how to do this. Ay by. Okay, we're going to press that equals what? 2 and 3. Alpha 2, alpha 3. Enter, enter. I say that's okay. So the integral is set up like this: 0, 2, 2, 3, integral ax. Now isn't that easier than this here? I think so. I'm going to say that's okay. Now we're going to integrate the function with respect to y first, okay? Which equals xy squared over 2 plus y cubed over 3. Now he's got that xy squared over 2 plus y cubed over 3 here. And it's over 2 and 3, the limits. At y equals 3, you put 3 in for all the y's in the function, and it turns out to be n times x over 2 plus 9. And then at y equals 2, it's 2x plus 8 over 3. Now notice that these have quotation marks around them which are entering for substituting for the y values. So you'd put parentheses there, okay? Left parentheses, right parentheses, and the 3 y squared times x over 2 plus left parentheses, y parentheses over 3 on your test or paper, okay? Now we subtract upper minus the lower. Here's the upper one we got, and minus the lower one. Turns out to be here. It's pretty cool, huh? So the new dx integral is 0 to, and here's the function, right? And we're going to integrate that, which equals 5x squared over 4 plus 19x over cubed. All right. 2 over 0. Looks like a 12 or something, but those are your professor generally writes that on a blackboard with a big long line like this with 2 over 0. You know, so I've tried to do that with this here. May change that. Maybe a little bit confusing. At x equals 2, and you substitute 2 for all the x's in here, 53 over 3. 0 equals 0. Upper minus lower, answer is 53 over 3. Here's the answer right here, okay? And then if you want to divide it out, here's 17.7 square units. Now they got volume here, so you'd put cubic units here. You know, you have to use your brain a little bit in calculus with these programs. You can't just be an idiot doing this stuff. So so you'd use volume here, cubic units, okay? So let's do new problem number 2. Let's do, and we're going to enter the function. Here's number 2, and the second part is calculate the iterated integral 3 over 0, 2x, 2. These are the variables here, and the function is y dy dx. Okay, alpha y. That looks good. Dy dx is number 2. You can scroll or press the number before the choices. And so we set up the double integral. Okay. We're going to enter the ax or y. That's 0 to alpha 0. Is that right? No. No, 3, 0 for x and 2x and x for... No, this is y. Okay, so we're going to quickly go through it and change it. Number 2, we're going to put integrated integral 3. Now they got 0 to 3. Actually, it's 3 to 0. It's going to change the minus sign here. So normally I would put, let's try it that way, alpha 3 and alpha 0. That's what you got to go through, and I say that's okay. Number 1, and then the next one is 2x and x. alpha 2 times x and alpha x. X over x, okay. Let's see what happens. The integral's set up now. Here we have it. We do the integration, y squared over 2, we integrated it, okay. That's going to be over x and 2x. Let's do it. Y equals x, we put that in for there, it comes up x squared over 2. And y equals 2x in for all the y's, and you get 2x squared. Upper minus lower, minus 3x over 2, 3x squared over 2. And that turns out to be the new integral. Okay? Now we're going to integrate that, which is minus x cubed over 2. And the range is 3 over 0. At 0, x equals 0, function equals 0. At x equals 3, it equals a minus 27 halves. Upper minus lower, 0 minus minus 27 over 2. Answer equals 27 over 2, 13.5 square units. Now we don't know whether that's put cubic units there, I guess, you know. So notice we had, they did it right, we had 3 over 0, and everything turned out to be pretty cool, huh? So anyways, go to my site, everystepcalculus.com, click on PayPal and buy my programs for $40. You'll never go wrong. You'll have them in your calculator for the rest of your life to be able to do this stuff for your grandkids, your kids, your partners, whoever takes calculus in the future. And you know, good luck in your classes and tests, okay? Have a good one. Of course, you can always call me too. Check and can't contact me through email or something. I'll help you with calculus all I can, okay? So, have a good one.